Chapter 7 is about quadratic equations, and Section 7.1 will cover the basics of solving quadratic equations. And so there are three objectives. Number one would be to solve quadratic equations using the principle of square roots and to find the x-intercepts of the graph of related functions. Then we learn how to solve quadratic equations by completing the square, and then we're going to look at some applied problems using quadratic equations. And that's really the reason why quadratic functions and quadratic equations are studied so much, because they're used a lot for mathematical modeling. We'll begin our discussion by looking at the graph of the function f of x equals x squared plus 6x plus 8 and its x-intercepts. So here we see the xy coordinate system, and here's the graph of the function f of x equals x squared plus 6x plus 8. And we notice that there are two x-intercepts, one at minus 4, 0 and one at minus 2, 0. Now, when we solve the, when we set the function equal to 0 and solve the resulting quadratic equation, x squared plus 6x plus 8, we can solve that quadratic equation by factoring. So we use the zero product principle. We set each factor equal to 0, and then we find that x equals -4 or x equals -2. So we see that the solutions of x squared plus 6x plus 8 equals 0, -4 and -2 are the first coordinates of the x-intercepts -4, 0 and -2, 0 of the graph. So in other words, the intercepts matter, and they're computed by solving this quadratic equation. And as usual, when we start a chapter, we look at some basic definitions. And here's the first one. A quadratic equation is an equation of the type ax squared plus bx plus c equals 0, where a, b, and c are real number constants, and a is greater than 0. And this is called the standard form of a quadratic equation. So when we talk about the standard form of a quadratic equation, this is what we mean by it. Let's look at exercise number 1. Below is a graph of f of x equals x squared minus 6x plus 8. And part A asks, what are the x-intercepts of the graph? Well, by inspection we see that the x-intercepts are 2, 0. That would be this intercept, and then the other one is 4, 0. And for the B part, we can look at the solution as follows. X squared minus 6x plus 8 equals 0. We can factor this into x minus 2 times x minus 4 equals 0. When we set each of the factors equal to 0, we find the solution x equals 2, and the other solution is x equals 4. I abbreviated these steps here a little bit because we've done it so many times using the zero product principle. So we set each of the factors equal to 0 and solve for the variable. So that's the answer to part B. That's the answer to part A. And for part C, what relationship exists between the answers to parts A and B? Well, the relationship is that the solutions of x squared minus 6x plus 8 equals 0 are the first coordinates of the intercepts 2 and 2, 0 and 4, 0. So 2, 0 is the first coordinate for this first intercept, and 4 is the first coordinate of the x-intercept 4, 0. So that's the relationship. For exercise 2, we, for the A part, x squared equals 16, we can write that as x squared minus 16 equals 0. And we can factor that into x minus 4 times x plus 4. And by setting each factor equal to 0, we find the solutions x equals 4 and x equals negative 4. So that's the answer to part A. And from looking at the graph for the B part, we find the first intercept is, so this is the A part, and for the B part, so the x-intercept is minus 4, 0, and the other intercept is 4, 0, x-intercept that is. And again, we find that the solutions are the first coordinates of the x-intercepts, like in the previous exercise. And then number 3, the way we can solve this quadratic equation, we factor the greatest common factor, and there would be 2x. So 2x times 2x plus 7 equals 0. And then setting each factor equal to 0, when we set 2x equal to 0, that gives us the two solutions, x equals 0, and the other one is x equals minus 7/2. So those are the two solutions for the part A. And then the intercepts, from looking at the graph, again we find that minus 7/2, 0 is one x-intercept, and the other one is clearly the x-intercept 0, 0. So that's the answer to the B part. In exercise number 4, when we write the quadratic equation in standard form, we get 5x squared minus 8x plus 3 equals 0. And we can factor this trinomial into 5x minus 3 times x minus 1 equals 0. And when we set each factor equal to 0, then from the first factor we get x equals 3/5. And the other solution would be x equals 1. So these are the answers for the first part for A. And then to find the x-intercepts of the graph, again, we find that for the B part, the x-intercept, the first x-intercept is 3/5, 0, and the other intercept is 1, 0. Again, we find that the solutions to the quadratic equation are the first coordinates of the x-intercepts. Next, we look at the principle of square roots, and that is the solutions of the equation x squared equals d are the square root of d and minus the square root of d. So when d is greater than 0, the solutions are two real numbers. When d is equal to 0, the only solution is 0. And when d is less than 0, the solutions are two imaginary numbers. We discussed that before. So Here now we see some applications to quadratic equations. And so we often use the notation plus or minus square root of d to represent both square root of d and minus the square root of d. It's kind of a shorthand notation, and so it's okay to use that. Here's a guided solution as an example of the principle of square roots. So solve the equation 5x squared equals 15. Gives the exact solutions and approximate the solutions to 3 decimal places. So first of all, we have 5x squared equals 15. By dividing both sides by 5, we find that x squared equals 3. So then x is the square root of 3 and minus the square root of 3. So the solutions can also be written as plus or minus 3. And then when we take the square root and round to 3 decimals using a calculator, then the answer would be 1.732, and that's plus or minus. Again, which is a short form or shorthand notation of 1.732 and or minus 1.732. For exercise 6, we write this as 3x squared equals 8. Then we divide by 3, so x squared is equal to 8 divided by 3. And then we take the square root, so then we get x is equal to plus or minus the square root of 8 divided by the square root of 3. Now, since we can write 8 as 4 times 2, or 2 squared times 2, we can now rewrite the numerator as 2 times the square root of 2 divided by the square root of 3, plus or minus, of course. Now let's rationalize the denominator, so that means we divide by the square root of 3, we multiply by the square root of 3. So this then becomes plus or minus 2 times the square root of 2 times 3, or 6, and the square root of 3 times the square root of 3 is equal to 3. So that would be our exact answer. And when we calculate the solution, we approximate it with a calculator, it would be plus or minus 1.633. So this is the exact solution, and this is the approximation to 3 decimals. For number 7, we write the quadratic equation by subtracting 1 on both sides. So 2x squared equals negative 1, or x squared equals minus 1 divided by 2. Then we take the square root on both sides. So x is equal to plus or minus 1 divided by the square root of 2i, because we are taking the square root of a negative number. And then when we rationalize the denominator, we get plus or minus the square root of 2 divided by 2i. Number 8, when for the a part, we take the square root, well, let me rewrite it, x minus 1 squared equals 5. Taking the square root on both sides, we get x minus 1 equals plus or minus the square root of 5. So that means x is equal to 1 plus or minus the square root of 5. So that's it for the A part. For the B part, we are asked to find the x-intercepts of this graph here. So in other words, we have the first coordinate, x coordinate for the intercept as 1 minus the square root of 5, comma 0. There would be this one here, 1 minus the square root of 5, comma 0. That would be this one here. And then the other intercept would be 1 plus the square root of 5, comma 0. That's this one here. 1 plus square root of 5, comma 0. For exercise number 9, we notice that x squared plus 16x plus 64 equals 11 can be written as x plus 8 parentheses squared equals 11. So when we take the square root on both sides, we find it's x plus 8 equal to the square root of 11, or x plus 8 equals minus the square root of 11. So x equals minus 8 plus the square root of 11, and x equals 8 minus the square root of 11, which can be written as minus 8 plus or minus the square root of 11. So far, the only technique we've learned for solving quadratic equations is factoring or using the square root principle. The third way to do this is, well, it's kind of a combination. It's called the method of completing the square. So here are the steps. To solve an equation of the form ax squared plus bx plus c equals 0 by completing the square, number one, if a is not equal to 1, multiply by 1 divided by a, so that the x squared coefficient is equal to 1. That means we have to divide each term by a, not only the first one, of course. So once the x squared coefficient is 1, add or subtract to that the equation, so that the equation is of the form x squared plus bx equals minus c, or x squared plus b divided by a, x equals minus c divided by a, if step 1 has been applied. So notice that every term gets divided by a, unless x squared, this coefficient, is equal to 1. Then take half of the x coefficient, that is this part here, and square it. Add the result on both sides of the equation. Then express the side with the variables as a square of a binomial, and then use the principle of square roots and complete the solution. That may seem a little complicated, but if we do some examples here, you'll see how it works. So the first exercise is number 10, and let's complete the square on this one here. So first of all, we notice that the coefficient of x squared is equal to 1, so we don't need to divide the equation by, or multiply by 1 divided by a. Following the suggested steps, we rewrite this quadratic equation as x squared plus 6x equals 8, minus 8. And now we take 1/2 of the coefficient of x, so 1/2 of 6, so 6 divided by 2 is equal to 3, and we square it, so plus 3 squared. and we add that to both sides. So then on the left side we have x squared plus 6x plus 9, and so that's minus 8 plus 9, which would be equal to 1. So now we can write x squared plus 6x plus 9 as x plus 3 squared equals 1. Now when we take the square root on both sides, we get x plus 3 equals plus or minus 1. So that means that x equals minus 3 plus or minus 1. In other words, when we have the minus sign, we get x equals minus 3 minus 1, or x equals negative 4. The other solution would be minus 3 plus 1, which means x equals minus 2. So these are the two solutions to number 10. For the guided solution, exercise number 11, we are solving x squared minus 8x minus 20. So we add 20 to both sides. We have x squared minus 8x equals 20. Then we take 1/2 of the coefficient of x, which means of 8, and we square it. So half of 8 is 4, and 4 squared is equal to 16. That gives us x minus 4, parentheses squared, equals 20 plus 16, or 36. So when we take the square root on both sides, we get x minus 4 equals 6, or x minus 4 equals minus 6. So in one case, where we now add 4 to both sides, x equals 10, 4 plus 6 is 10, and then if we add 4 to both sides, we get minus 2. So these are the two solutions of this quadratic equation. To solve the quadratic equation x squared plus 6x minus 1 by completing the square, we begin by writing it as x squared plus 6x equals 1. Now we take the coefficient of the x term, and it would be equal to 6 divided by 2. 6 divided by 2 is 3, so we square 3, so 3 squared equals 1 plus 3 squared. Again, we derive this quantity by dividing 6 by 2. So in other words, we have x squared plus 6x plus 9 equals 1 plus 9 is 10. So then we can write this as x plus 3 squared equals 10. And so, that's the reason why we call this completing the square. So we have the square of a binomial. And so now we take the square root on both sides. Then x plus 3 equals plus or minus the square root of 10. Then we subtract 3 on both sides. So x is then equal to minus 3 plus or minus the square root of 10. There are two solutions. In other words, one solution is minus x equals minus 3 minus the square root of 10, and the other solution is x equals minus 3 plus the square root of 10. But again, the shorthand notation plus minus 3 plus or minus square root of 10 is very compact, and it's easily understood that it means for these two solutions. For number 13, we notice that the coefficient of x squared is not equal to 1, so that means we need to divide each term by 2, or multiply by 1 over 2, so then that becomes x squared. and 6 divided by 2 is equal to 3, equals 5 divided by 2. Now, to complete the square on the left side, we divide the coefficient of x by 2, which would be 3/2. So x squared plus 3x plus 3/2 squared equals 5 divided by 2 plus 3/2 squared. So on the left side, then we have x plus 3/2 squared, and on the right side we have 5/2 plus 9/4. So multiplying by 2 in numerator and denominator would be 10/4, and 9/4 would be 19 divided by 4. So now we take the square root on both sides. So then x plus 3/2 equals the square root of 19, and the square root of 4 is equal to 2. That's plus or minus. And now we subtract 3/2 on both sides to isolate x. So x equals minus 3/2 plus or minus the square root of 19 divided by 2. And we will solve number 14 in a similar way. Again, we notice the coefficient of x squared is not equal to 1, so we divide the whole equation by 3. So we wind up with x squared minus 2/3 x equals 7 divided by 3. So we have x squared. So we take the coefficient of x, 2/3, minus 2/3, and divided by 2. That gives us 1/3 squared, 1/3 squared, and that would be equal to 7/3 plus 1/3 squared. And so then on the left side we have x squared, no, x minus 1/3 squared. And then on the right side we have 7/3, and 1/3 squared is 1/9. So combining 1/9 and 7/3 would be 22/9. When we take the square root on both sides, we'll have x minus 1/3 equal to the square root of 22, and the square root of 9 is equal to 3, plus or minus. So then in the final answer we have x equals 1/3 plus or minus the square root of 22 divided by 3. To conclude section 7.1, we're going to look at some applications and problem solving. And there's a very interesting function relating an athlete's vertical leap v in inches to hang time t in seconds. And that's the relationship v of t, the function, the vertical leap as a function of time, is 48 times t squared. So here's what we can do with it. Let's say Blake Griffin of the Los Angeles Clippers has a hang time of about 0.878 seconds. What is his vertical leap? Well, so we need to use this relationship here. So we asked what is v equal to. So v is equal to 48 times, and the time in seconds is 0.878 squared. So that is equal to 37.0024, or approximately 37.0 inches. So a little bit over 3 feet. Quite a vertical leap. For number 17, again we look at the formula v equals 48t squared. And since we are asked to find out what the time is, we solve the equation for t squared first of all. So it'll be equal to v divided by 48. And since the vertical leap is 40 inches, would be 40 divided by 48. And that is equal to 5/6. So then t would be equal to the square root of 5/6. And that's equal to 0.91287. So it would be approximately 0.913 seconds. So it's almost 10 seconds. That's really quite a long time when you think about it. Of course, he's also jumping way over 3 feet into the air. So, well, no, well, 0.9 seconds. Sorry about 1 second. And this concludes section 7.1.